as a quick walkthrough of my Unit 3 projects. So at the beginning here, we imported pandas and NumPy. We took a look at the data frame, we saved it here, took a look at it. We laid out some definitions here, and then we laid out our plan for what graphs and charts to use for the data. Going down, we imported Seaborn as well as matplotlib, and we set Seaborn as the actual standard plot type, and we have this function, the matplotlib inline, in order to have everything show up on its own, so we don't have to do plot.show. I was looking here at the bins and which number of bins would give me the best plot. So after that, I created this plot for the age. I added a KDE to it. Here we did that for the industry column. Here I chose to do a pie chart, and from this we can see that the data is separated in quarters for each of the industry sectors. Later on, we see the salary function. Here I decided to do a histogram, and I also plotted a KDE to show how the distribution works. It's mostly a normal Gaussian plot right now, and I also printed the mean. Later on, we did that for the industry experience as well. I did the volume plot for this. It showed the mean to be at almost 18.4 to be exact, and that's a distribution, so most of the people lied between, I'll say, 10 to 30. The others were a lot less common for the experience. And for the age, I just took a quick value count of that, and I graphed it as a pie chart. So people with a bachelor's degree were the highest. I had to do the value counts in order to fix my labels here, since I needed to learn how it started. But for the most part, I figured out that it started from the highest to the lowest. So I had started with bachelor's, master's, some college and high school, and that's the counts. And I also had the percentages show with the auto percent function. Also added the shadow, and I just took the 3% of the high school out with the explode right here, and I also gave a little space for the some college work. Also, we did the plot for the genders. We found they're equal. They're basically 50% each for the data here. I also laid out the definitions, more definitions here. Did the describe function to see the data for the age. Did the box plot for the age. And this is the standard deviation, this is the mean, max, and min, and I used the median here to find out what the median is, which is 47 in this case. Same thing for the other plot here, and I wrote all of this here. And right now we're grouping by the industry, and we're grouping salary with the industry, and we're using a describe function on that. And that's how it looked as we graphed it. We also did that for salary and education. That's the graph, as well as salary and gender. For part 3, we laid out these definitions. We did the crosstab function, basically merged them inside one plot. We did the strip plot between Asian education, that's how we did it. We have education as a y-axis and age as a x-axis. That's how it looked. And here we can see a pretty good relationship. The higher the education, the higher the age. And that's a positive correlation between age and salary. The older you are, the more salary you get. And that's the conclusions we had to get out of it. Experience and salary, positive, as well as experience versus age. And one cool thing is that this is the strongest correlation with the data, which makes sense. The higher the age, the more experience you have. And I also did that for the industry and the salary. And right here I can see that tech was the highest paying industry, followed by finance, business, and then healthcare at the end. We also laid out some more definitions here, and we had to import the salary numeric.csv. We imported Pearson-R, Spearman-R, and we use these to get the p-values and the correlation values. So right here we can see that the p-value is pretty close to 0 for salary and education, and our threshold was basically 0.05, so it did pass, and we can take by our hypothesis right here. Same for the second one, as well as the third one. So we found out that basically all the null hypotheses were false, or we can reject all of them, and we can take by our hypotheses. We also laid out some definitions here. We did the pair plot for all data using the numeric function, numeric.csv, and we also did that for the correlation graph. We did the heat map for that. Here you can see that the Asian industry experience was the highest one. We also did the heat map right here, but with the crosstab of education and industry. So we grouped these. Industry on the y-axis is education level, and the colors right here are basically denote the salary, and we use this function to show the whole number and not e to the power of something. And at the end we laid out our findings.